This segment will discuss how queries in SQL are processed, and more importantly, techniques for optimizing query performance. Queries written in SQL are turned into results via a multi-step linear process. The first step is to process, validate, and translate the SQL into an intermediate form. This intermediate form is used by the optimizer to produce an execution plan, which is then input to the code generator and produces computer code to execute the query. Finally, the code is executed, and the results return to the requester. Much of what databases do is classical information processing, namely sorting and searching. There are several efficient algorithms developed over the years which are used to accomplish these tasks. However, it is useful to understand that the performance of algorithms used to search database tables directly impacts the performance of a database. Algorithms for performing selection and join use searching algorithms, and a cost of the various algorithms is developed, which can be used later as input to a query optimizer. The intermediate representation of a query in the relational algebra provides the opportunity to perform heuristics that improve query performance by rearranging the order of the operations using the rules of the relational algebra. This technique is called an heuristic because it exploits rules such as only projecting the columns necessary for a query rather than processing the entire table, which is a common sense approach to reducing processing time. Since the operations in a query can be performed in different orders, another approach to optimizing the query is to attach a cost to the various sequences of the operations and choose the least cost approach. These costs are developed using the time it takes the algorithm to process the table based on the size of the table. In other words, the number of rows and columns.